Good day, class. Let us now continue our lecture. This time, let's discuss how to solve for the resultant by rectangular component method. Previously, we learned that there are three methods of vector addition or solving for resultant. Now we will tackle this last but very useful method, the rectangular component method. To see the capability of this method, let's consider this figure in where four forces are acting at point A. Imagine how lengthy will be the process if you are going to solve the resultant using either parallelogram law or triangle rule. And even you will be successful in making the correct drawing using either of those two methods, you might experience difficulty in finding the most practical trigonometric solution to save time. Therefore, if several forces are present, it is both practical and convenient to solve for the resultant by utilizing the rectangular component method. This method can be performed in 5 steps. First, find the resultant along the horizontal or x-axis by summing all the horizontal components of the given forces. You may designate all forces directed to the right as positive, thus forces directed to the left are negative. Second, find the resultant along vertical or y-axis by summing all the vertical components of the given forces. You may designate all forces directed upward as positive, thus forces directed downward are negative. Third, after reducing all the given forces into two components, the magnitude of the resultant can now be solved using the Pythagorean theorem. Fourth, solve for theta, which is an acute angle of inclination of the resultant with respect to the horizontal. In this case, this formula can be used, and notice that the absolute symbol in the formula is used. This is used to ensure that an acute angle will be obtained once this is operated using your scientific calculators. Take note again, if you're going to use this formula, the angle theta that you will obtain is acute and with respect to the horizontal. Lastly, determine the position of the resultant. Same as the coordinate system in analytic geometry, the axes divide the plane into 4 quadrants. If both components are positive, the resultant is located at the first quadrant, and the rest of the quadrants follow the same convention of the coordinate system in analytic geometry. In this example, it is just assumed that the sum of all x components is positive and the sum of all y components is negative, which locates the resultant within the fourth quadrant. But in case this assumption is wrong, and that the sum of all x and y components should be negative, then the resultant must be repositioned inside the third quadrant. To apply these steps, let's solve now a sample problem. In this problem, 4 forces act on bolt A as shown. Determine the resultant of the forces on the bolt. As practice, let's start by writing what is required. We are tasked to solve for resultant R of all given forces. For the solution, let's simply follow the 5 steps discussed. The first step is getting the resultant of all x components, let's denote the rightward direction as positive. This summation can be expressed as sum of x components of f sub 1, f sub 2, f sub 3, and f sub 4. Notice that x is included in their subscripts to denote that they are x components of the given forces. This time, let's substitute in this equation the required values for each term. By applying trigonometry, we can write that the x component of f sub 1 is positive 150 times cosine of 30 degrees. For f sub 2, we should write its x component as negative 80 times sine of 20 degrees. Kindly take note of the orientation of force f sub 2 in this figure. Then for f sub 3, it can be observed from the drawing that it is acting purely along the vertical. Thus, it has no component along x-axis. Lastly, for f sub 4, its x component is equal to positive 100 times cosine of 15 degrees. So by adding these values, we get the total x component of the forces equal to 199.30 newtons. For the second step, let's denote upward direction as positive. Then, the same with the first step, we express this summation as follows. This time, y is included in their subscript to denote that they are y components of the given forces. By applying trigonometry, we can write that the y component of f sub 1 is positive 150 times sine of 30 degrees. For f sub 2, we should write its y component as positive 80 times cosine of 20 degrees. Then, for f sub 3, since it is acting purely along the vertical, we should write negative 110. Lastly, for f sub 4, its y component is equal to negative 100 times sine of 15 degrees. By adding these values, we get the total y component of the forces equal to 14.29 newtons. Now for the third step, let's solve for the magnitude of the resultant using the Pythagorean theorem. In this formula, let's just substitute the total x and y components. This gives a magnitude of 199.64 newtons. Then to define the inclination of the resultant, let's solve for the acute angle theta by applying this formula. By substituting the total values of x and y components in the formula, we get that the angle theta is equal to 85.90 degrees. Always take note the absolute symbol in this formula and that theta is an acute angle with respect to the horizontal. To fully describe the direction of the resultant, we just need to look at the signs of its total components. Since both components are positive, the resultant is located in the first quadrant. In the given drawing, the resultant can be positioned in this manner, and the final answer can be expressed as 199.64 newtons 85.90 degrees with respect to the positive x-axis. In this lecture, please kindly go back to the objectives to see if you can recall your knowledge about trigonometry, if you can resolve a single force into either oblique and rectangular components, if you become familiar with 5 steps of getting the resultant by component method, and if you can reduce the given forces into its components using trigonometric functions and evaluate their sum. I hope you learned something new from this lecture. Despite of your workloads, may you gain clarity from these words of Confucius. So that's it for now, class. God bless future engineers.